Assalamualaikum warahmatullahi wabarakatuh. My name is Nurlidia Shafika binti Muhammad Abdul Aziz. So I will explain about stress acting on fiberglass table set, which is our structure that we choose. As we know that fiberglass has a high tensile strength, which is can withstand significant amounts of stretching or pulling force without breaking. As we put some load on the table or seat, it will able to maintain its original shape. Because of the design of the table needs to consider how the load is distributed across its surface. The engineer calculate the stress by dividing the applied force over the area that it acting on. The characteristic of fiberglass materials such as tensile strength, compressive strength, and modulus elasticity directly affect how the table respond to the external force. That's all for me. I will pass the presentation to the next presenter.
My name is Amira. My metric number is TM22025. So today I'm going to explain briefly about strain inside the four-seater fiberglass chair and table that we are doing. So strain in this context is a deformation or change in shape under force. So there's two types of strain that we can observe. The first one is compressive strain. This occurs when the fiberglass is squeezed. Example, when someone is sitting on it, and then we need to take account of the amount of strain depends on weight of occupants, how heavy they are, the seating design, whether the seats are wider, because the wider the seats, the more bending compared to narrower, and then the support designs, and then the material properties such as fiberglass and steel that we have been used to know the bending strength, and then the thickness of the materials and to know the bending force. And then there's second one is shear strain. This occurs when connection points between seat supports and the base, particularly if sideways force are applied. As for example, when people are pushing against the seats. So what happens if there's excessive strain? It can happen deflection, cracking, about the fiberglass can crack, then bending and shear stress can exceed its strength, and failure in extreme cases. That's all from me. Thank you.
My name is Ashikin and my metric number is TM22005. Today, I would like to explain about torsion in four-seater fiberglass table sets. Torsional strength in fiberglass table sets refer to the material's ability to resist twisting or rotational forces. These forces may come from various sources such as uneven weight distribution, leaning or pushing, and also uneven ground. The factor that will affecting torsional strength in four-seater fiberglass table set is, the first one is thickness of the tabletop and also the leg. The thicker the component will also effect on the greater resistance to twisting. The second one is fiberglass quality. The higher the quality of the fiberglass will provide the better torsional strength. The third one is the tabletop shape. Round tabletop tend to be more resistant toward torsion rather than the rectangular one.
Hi, my name is Azmi and my ID is TM22020. So I will taking part on bending. So what is bending? Bending is the behavior of a cylinder structural element subjected to an external load applied perpendicularly to a longitudinal axis of the element. So based on our object, which is stable, we can get four factor of bending, which is material properties, environmental factor, long-term stress, and construction quality. So based on material properties, it is based on the material what we choose. On our object, the material that we choose is plastic and uh, iron. And for the environment factors, the factors that be common is like temperature and the humidity. For long-term stress is like load distribution, and the construction quality is on how the design is specifically create on the object which is stable. Alright, that's all.
Hi, my name is Siti Hudzaifa Betty Rosli. I'm going to talk about the bending. The first one is load distribution. Bending analysis consider how the table respond to distribute loads, such as people sitting along the edge or placing items unevenly on the surface. Engineer evaluate how well the table can distribute this load to prevent excessive bending. The next is structural component. The design of the table, legs, frame and any additional support structure is crucial for resisting bending force. Engineer use structural analysis to ensure that this component can handle the expected load without failing. Lastly, the geometry adjustment. Optimize the table geometry to enhance its ability to resist bending. This may involve adjusting the thickness and shape of structural components.